availability zones or separate facilities within an AWS region. And we do that by mirroring the storage and mirroring the database itself. So when we talk about Aurora, well, Aurora is kind of special in that it uses a completely different storage layer. The storage is a shared storage volume that sits across all of the availability zones within a region. And then we attach instances to that shared storage. And this gives us significantly faster recovery in the case of a loss of a machine, as well as much higher availability and much higher scalability. The other thing that Aurora does that's really interesting is it has much lower replica lag, or the time it takes for a change made in the primary to be propagated to the standby read replicas within a given region and cross availability zone. So that's Aurora. Serverless is coming soon. It's currently in preview. We wanted to give everybody a little bit more info on what that is. So the idea of serverless is, what if we could take the database and break all of the things that tie you to having to think about capacity, having to think about where it resides, and instead just be able to focus on the tables and how you issue queries against it. So if we look at a picture of serverless Aurora, we can see that it is really quite different. We have a application that is able to connect to what we call a VPC endpoint for serverless Aurora. And this is going to be the endpoint that you see as being your serverless Aurora database. And what that does is it terminates your client connection on a network load balancer and a new thing called a request router. And these request routers do all the hard work of making sure that you can communicate with the database, even if that database is torn down and is not running while it's idle.
And does this use all the standard clients and libraries to connect into this database?
Yeah, absolutely. So the great thing about the Aurora serverless application is it's not going to require that you rewrite your applications to use this feature. So we'll continue to support JDBC and ODBC from the client's perspective, but in the back end, we'll be able to do something very, very different with the database.
Excellent.
We've got a question on the stream here. One of our viewers asks, when you're talking about making things significantly faster or reducing lag to use the service, what kind of performance improvement is observed over, say, traditional RDS, the kind of multi-node RDS model that we have?
Sure, yeah, great question. So we can see replication lags of less than 10 milliseconds with the Aurora engines, and then the variability that you can get in the replica lag for RDS engines can really be dependent upon the type of instance that you provisioned, as well as the different types of storage. You don't just have to pick one type of storage underneath your database. You can have SSD storage, you can have spinning magnetic disk, and so on. And so that can be a function of
and I guess with Aurora, the load, the heavy lifting associated with managing that replica is not running in the instance, is it? It's running separate to the instance.
Correct.
So you're not paying for those compute cycles in your database instance.
That's right. The replica propagation is all happening down in the Aurora storage tier.
Yep.
Your database can then just spend its time focusing on SQL queries and making the writes that your application kind of need to come back quickly.
Great, excellent.
So I guess many of our listeners are used to using RDS and scaling in RDS and know what to do with those workloads there. But what about Aurora Serverless? How do we scale in that?
Yeah, good question. So the thing about Aurora Serverless is it's designed to scale on demand. So now with the RDS service, we support auto scaling, which is where we can scale the fleet horizontally based upon how you use it. Well, serverless takes that really to the next level, and I'll show you another picture about how this works. In that, when we're running with a certain amount of capacity in serverless, we can just transparently, in the background, spin up a brand new instance that's larger to offer you more capacity for when you have, slightly peaky workloads or variability. So it feels a lot like the auto scaling feature from standard RDS, but we're also able to do it within a single instance.
And is that pulled from a hot pool of servers, so it's a nice quick start time there?
Yeah, exactly. So we have a very responsive scale up and scale down as needed. So we can usually bring something online within about 5 seconds of when we see the capacity be needed within the system.
That's pretty cool. So the big one that I'm sure we're all wondering, how's it priced? How are we charged for this,
Sure.
this new service?
Yeah, so good question. So we have a new concept with Aurora Serverless, which is called an Aurora Compute Unit, okay, an ACU. And an ACU gives you the ability to run a certain amount of RAM, for example, and a certain number of cores. So one ACU you should think about as being one virtual CPU and 2 gigabytes of RAM. And then when you provision this environment, you decide what range of ACUs you want in your serverless environment.
So that's like an upper and lower bound on your auto-scaling group.
Upper and lower bound, exactly. Another picture, if people want to see what the configuration looks like, we set up in the capacity settings the ability to say the minimum capacity units and the maximum capacity units. And then you can see there we're showing that how that's priced on a per hourly basis for that number of ACUs.
It's nice and transparent. It's nice to have it there in the console.
Yeah, indeed. And now billing for those ACUs is going to be per second billing with a minimum of 1 minute when you use the database. So if we've scaled completely down to nothing, you won't be charged for the ACUs. And then when you use that capacity, when you issue a query, you do a write, then we'll start up that environment, and then that's the point at which we'll start billing the per second billing for the ACUs.
What's the typical latency in responding to that first query or write then? Is that the spin-up time?
Yeah, so you know, one of the things that's quite amazing, another picture is, you know, we keep the Aurora serverless connections open and ready to accept client commands, even when the system is completely deprovisioned and you are not being charged for ACUs. And then when we see a query come in, we can bring online that capacity in around 5 seconds. The same sort of hot pool management process that we use for scaling up and down is used to start and completely stop the service as well. And so
as long as our client can handle that 5 seconds to it, for all intents and purposes, there's no difference to a normal database that's
Absolutely.
live.
That's transparent to the client because you said the TCP connection is still open, right? So
Exactly.
it actually looks like query latency. There's no reconnect. It's just
exactly
latency on
that,
first
yeah.
query.
So a really important point that your application will continue to be connected even when Aurora Serverless has scaled down to 0 and you're only paying for the storage capacity that's in use.
Yeah.
And then when you fire that up, you'll just perceive that it takes a particular statement. That first run latency will be about 5 seconds, and then from there it should be whatever capacity you need based upon your ACU configuration.
And with the storage charges, is that based? Is that very similar to EBS type storage, or is it a separate model?
Yeah, so it is slightly different in that Aurora storage is always multi-availability zone.
Okay.
And so you always get regional high availability from Aurora storage. So the pricing is then like EBS and with serverless, like non-serverless Aurora, you're paying per gigabyte of storage that you're using on the storage volume.
Yeah.
But what's really nice about Aurora is that there's no need to over-provision for whatever you think you're going to use in future, because the Aurora storage volume will scale as you add data to it in 10 gigabyte chunks. So it's as big as it needs to be to store your data, and you can start very, very small, and then scale all the way up to 64 terabytes in standard Aurora RDS without ever having to resize a volume like you would in a normal database, either on EBS or in the cloud.
So that's a bit of operational heavy lifting that customers don't need to focus
Absolutely,
on.
yeah, and that's true for Aurora more generally,
Yeah.
for MySQL and for Postgres engines.
And as you say, the connections are kept open. I expect that to then work with, as it scales, my connection is still open, so there's no blipping connectivity from my application.
Correct.
I don't have to handle that in the app.
Yeah.
So that's all there.
Yeah, that's right.
And I've even got that when it's shut down. That's really handy
Absolutely.
for developing, yes.
Absolutely.
So what type of use cases? Who can use Aurora Serverless? Who's it
Yeah.
good for?
Yeah, so this is a really powerful capability for the types of systems where you infrequently use your database. So for example, if you have a system that you only need to do weekly reporting, for example, then the serverless database can come online, it can service that requirement, be metered by the second, and then shut down again and not be used. Or in cases where you maybe have a relatively low utilization use case, but then you get these massive spikes of capacity. Serverless is really amazing for that because we'll be able to scale in the background without you having to think about, well, my peak is sort of up here, so I need to provision that and keep that running all the time.
And I guess it's good for dev and test environments as well, because you can have that shut down in the evening when no one's working, and spin back up at 3 o'clock in the morning when the devs wake up.
Absolutely. We talk about not all dev and test environments are created equally, so you have test environments that are for functional testing, and this will be fantastic for that. You'll shut it down at nights and weekends, maybe using a standard model, but with serverless you won't have to. It will just shut itself down when it's been idle for whatever idle configuration timeout you set.
Oh, that's configurable, so you can
That is
control
completely
the cooldown.
configurable.
Okay.
That's right. Yeah, so it'll shut itself down when you're not using that, and then when you want to have an integration test or a SOAK performance test type environment, then you would use Aurora non-serverless so that you get this very predictable and dedicated capacity. So dev and test is absolutely a great workload for that sort of stuff.
Okay, so should I use it for everything?
Yeah, that comes up a lot, and we think it's a fantastic prospect for some of the use cases that we've mentioned, but equally, where you have very predictable or steady-state workloads and where latency is particularly important, then we would advise you to stay with the non-serverless Aurora environments. And there's a lot of different kinds of applications that you might use internally, your back office applications, for example, that might only get 5 to 10 to 100 hits a day for somebody to do a small piece of work. Well, that's fantastic for the serverless use case. Whereas something that you absolutely have to know that every time you issue a query, that's going to come back in a very predictable time frame, that's probably not the best use case for serverless.
There's a question on the stream, Ian, from David MCO65. He's asking about multi-region capability. So can you say a little bit about multi-region in Aurora more generally, and also how that reflects in multi-region capabilities for Aurora Serverless when it's available as well?
Yeah, absolutely. So with Aurora, we talk about having a primary, and then we have read replicas. And those read replicas, you can read from them, but when you want to do a write, you go back to the master to do the write.
Yep.
We pre-announced the idea of using multi-master Aurora, where you can write to any of those read replicas, and that will be coming soon as well. One of the things that Aurora can do today is allow you to create a read replica that's in a different region than where your primary is.
Yep.
And there are a lot of different use cases you might use that for, whether it's to get lower latency to your end user base that's in a remote office, for example, or just for regional redundancy.
Yep.
Today at GA for Aurora Serverless, this is going to be a single region database, and we'll look for feedback from customers and how we expand that in the future.
Okay,
Great. Absolutely. So yeah, you mentioned it's when it comes GA, so it's in preview at the moment. How's the preview going? What's the feedback from customers? Because we test our previews with customers, and I'd like to hear about that.
Yeah. So Aurora is still our fastest growing service ever in the history of AWS. And with that as the background, you may not be surprised to hear that the feedback's been pretty overwhelming. And so, we've been slowly onboarding customers and making sure that we can talk to them and understand what their use cases are as they're using the database, get feedback, and then also kind of tailor what we're planning as part of the roadmap for GA on the basis of that feedback. And we certainly had some really, great customers giving us feedback on what should be in and what's less
And there's a
important.
lot of things to do for GA as well, like integration with other services, making sure we've got cloud formation there, and we can
Absolutely.
customers can deploy that very, very easily through there. So I'm looking forward to this.
When you're talking about adoption of Aurora, how much of that is customers moving existing databases to Aurora versus new workloads? There's quite a few customers now coming out with commentary about how they've moved from existing databases into this new technology that we're providing. Is that something that you see a lot of as an SA leader?
Yeah, absolutely. So, one of the things that is really amazing is just how many customers are looking to migrate their databases to the cloud and really get more, freedom from, some of the commercial database vendors and the platforms that they've run on in the past. So, as an example, we have a service called the Database Migration Service, and that's done more than 60,000 migrations of databases to the cloud already, and growing month on month and week on week. So the split of net new workloads versus migrations, hard to say, but certainly migrating to Aurora in particular gives us the benefit of having inherently multi-AZ storage and very, very fast recovery and failover, which is something that's essential for mission-critical databases.
Really expensive with traditional approaches. Right?
Absolutely, absolutely. So Aurora is just a fantastic platform for when you're looking at how you take your, mission-critical production databases on premises and migrate those into the cloud. Aurora is a fantastic platform to do that.
And will I be able to go from Aurora standard, for want of a better term, to Aurora serverless and back? Very easy.
Yeah, good question. I don't know quite what the team is planning for that, but certainly, the RDS generally supports the concept of taking snapshots.
Yeah.
Snapshots give you the ability to do point-in-time recoveries to new databases, and I'm sure the team is looking at feedback on how we can take existing non-serverless database snapshots and be able to stand those up using other engines.
Well, I'll definitely add that to my AWS wish list. So you'll see that come through.
Good.
Yeah. When's it going to be ready?
The million,
the $1 million question.
The question
there,
on everybody's list.
Yeah.
So we're targeting late Q2 of this year for general availability.
Okay.
Watch this space. We're always taking feedback, and with all AWS services, we try and make them ready when they're ready. That's the plan currently, and it's looking good.
And what availability zones will we be going for?
Yeah, so we're going to be offering this in a limited set of regions initially.
Yeah.
And that'll be Oregon and Virginia in North America, and then in Dublin here in Europe, and then also launching in Sydney as well around the GA time. But ultimately, we'll be then fast rolling out week on week to all of the regions where Aurora is currently supported. So really looking to have that there as quickly as possible because the demand is very, very high.
Sounds great. Okay, we're going to go to some questions from Twitch now. So, Ian, what have we got?
Yeah, we're pretty much up to date, actually, on all of the questions that we have. One that's just come in. How does Aurora Serverless keep these instances in sync that are brought in and out of the capacity pool that's made available? Can you say a little bit about that?
Yeah, so
how is consistency handled across the different instances?
Yeah,
that are
absolutely. If we go to the image of how the cluster configuration works, one of the things that's really powerful about having this shared storage volume is the fact that we don't just have to use that for data. We can also use it for cluster consistency information. So when we scale up and scale down, the Aurora storage is able to contain the information about the last consistent spot for a given database. And then when a new instance comes in, that information is shared via the storage layer, and it's able to make itself consistent and proceed from that point. And again, that's all something that's handled completely by the service. That's something that's handled by Aurora non-serverless as well, because we can obviously scale up and down those read replicas, and those are always going to be transactionally consistent, though they may lag behind the master by a small
amount. That's the underlying reason for the rapid failover between nodes, right? Because
Absolutely.
there's no need to consistency check the volume as you attach it to a new host, because the volumes are permanently attached to all hosts at all times.
Yeah. Very well said. And that architecture of being able to do a limited amount of operations during a recovery is one of the things that we really looked at database technology over the last 30 years and said, well, what if we reimagined this for the cloud? How would it work? And where would we want to have to do this kind of work? And so, in fact, Aurora Storage is really quite interesting in that rather than performing this very lengthy consistency checking in order to be able to make a node able to read from the database, it's always doing that work in the background. It's just one of the tasks that it's doing. So even if a particular storage node, we put data on 6 machines in 3 separate availability zones, even if one of those happens to have missed an update, if it detects that happens, it gossips with its neighbors and says, hey, give me these values, and it will take itself out of the read pool until that happens. So it will stop saying, hey, I've got most up-to-date data if it thinks it hasn't. So it's constantly repairing itself and making sure that it's consistent and up-to-date, which radically changes the recovery profile when we want to just activate across a different availability zone. And then we're using that here for this ability to just scale nodes up and down, including down to nothing.
Right. So there's quite a lot of excitement here on Twitch about it, and particularly in what regions it's going to come out. We've got Mr. Chris Pill who wants to come out in CA Central, please. So add that one to the list.
Good. Yes, indeed.
It sounds like a great place. I mean, I can think of several workloads that you potentially run on there. my background's with media, and we had a lot of sites where you updated the database once, but everything else was a read, unless you cached it. So it's a great use case for loading that into cache, spinning down the database and saving some money there, and serving from cache. So there's some great use cases here.
Yeah, absolutely. Yeah, it's a great way to hopefully help you get much more elasticity for the applications that can handle a bit of a trade-off of slightly higher latency in some circumstances, and also where you just don't want to have to think about this. So much more flexibility, much more taking away you having to plan up front.
Yep. Great.
That's great.
Okay, so I think we'll wrap this segment up there and give our next presenters a couple of minutes to get up on the Launchpad stage here at the AWS Summit in London. Thanks for joining us. We'll be back at the top of the hour. See you soon.
Thanks.
Thank you.